first violation pertains to the location of the main distribution panel. According to National Electrical Code, or NEC, section 680.44b2, the main distribution panel must be located at least 12 feet from the nearest edge of the spot. If the spot is situated within 12 feet of the panel, this constitutes a violation of the code. The second violation concerns the exhaust fan. NEC section 680.43b2 dictates that an exhaust fan installed above a spa must be listed for use in damp or wet locations. Furthermore, it should be positioned at a minimum height of 6 feet above the top of the water level. If the exhaust fan is not specifically listed for damp or wet locations and is mounted within 5.5 feet of the water level, this is a code violation. In addition, the switch for the fan cannot be within reach of the tub, which would be another violation. The third violation is related to the branch circuit feeding the spa. NEC section 680.44b specifies that the branch circuit must have ground fault circuit interrupter, or GFCI, protection by either a breaker or a receptacle. If the sole means of this connection is a 2-pole 50-amp GFCI breaker located at the panel and it's not visible from the spa, this is a violation. Furthermore, NEC section 680.44b3 mandates that any outlet must be positioned within 2 feet of the inside edge of the spot and no more than 6 feet above the top of the water level. If the outlet is mounted on the wall surface, situated above the water level, and within 2 feet of the spa's exterior, it is a violation. The fourth violation involves the use of non-metallic, or NM cable. NEC section 680.22b states that NM cable is prohibited in wet or damp locations unless it is explicitly listed for such use. If NM cable is exposed, traversing the spot and running inside a sheet-rocked wall, it violates the code. NEC section 680.22b also pertains to the Carflex, requiring it to be listed for use in wet locations. If the Carflex in question isn't listed for wet locations, there is a violation. There are also additional concerns. Firstly, there should be bonding between the spa and the house's electrical system. Secondly, an unfinished basement may lack ventilation, which could lead to moisture problems. Here are some recommendations. Firstly, relocate the spa to a location situated a minimum of 12 feet away from the main distribution panel. Secondly, install a GFCI outlet no more than 2 feet from the inside edge of the spa and no more than 6 feet above the water level. Thirdly, install a dedicated disconnect switch which is visible from the spa. Fourthly, use NM cable that is listed for wet locations or use an alternative wiring method such as conduit. Fifthly, route the Carflex in a manner that ensures it is not exposed to moisture. Sixthly, bond the spa to the electrical system. Seventhly, improve ventilation in the basement to prevent moisture issues. Delving into more detail on each of these points, let's begin with the main distribution panel location. The 12-foot rule is in place to prevent accidental contact with live electrical components while someone is wet, which significantly increases the risk of electric shock. Water is an excellent conductor of electricity, and the human body's resistance is much lower when wet. This is why electrical codes have stringent requirements for electrical installations near water. The code uses this distance to create a safety zone, minimizing the possibility of electrical hazards. In practice, this means carefully planning the location of the spa relative to the existing electrical panel during installation or renovation. If the panel must be closer than 12 feet, it may require physical barriers or relocation of either the panel or the spa to comply with the code. Moving on to exhaust fans. The requirement for damp or wet location listing is crucial. Standard exhaust fans not designed for such environments can quickly corrode and fail, creating a shock hazard. These fans are specifically designed to withstand the high humidity and potential water exposure typical of spa areas. The listing ensures that the fan's components, wiring, and housing are sealed and insulated appropriately. The height requirement of 6 feet above the water level further minimizes the risk of water splashing onto the fan, which could lead to electrical shorts or corrosion. This also helps to prevent someone from accidentally touching the fan while in the spa. Regarding the fan switch location, preventing the switch from being within reach of the tub is a safety measure to prevent users from operating the switch while in the water. This reduces the risk of electrical shock if there is any fault in the switch or wiring. The use of GFCI protection is another essential layer of safety, as it quickly cuts off power in the event of a ground fault, protecting users from potentially lethal shocks. Now, concerning the branch circuit and GFCI protection. GFCI breakers and receptacles are designed to detect even small imbalances in current flow, which can indicate a ground fault. When a ground fault is detected, the GFCI trips, cutting off the power in milliseconds, thereby preventing electrical shock. The requirement for a visible disconnect switch near the spot is to provide a readily accessible means of cutting off power to the spot in case of emergency or for maintenance. This switch should be clearly labeled and easily accessible to anyone using the spa. The location requirements for the outlet, being within 2 feet of the inside edge of the spot and not more than 6 feet above the water level, are intended to provide convenient access to power for spa equipment while maintaining a safe distance from the water. This also helps to minimize the use of extension cords, which can create additional hazards. Now let's discuss NM cable. NM cable, often referred to as Romex, is commonly used for indoor wiring in dry locations. However, it is not designed for use in wet or damp environments. The paper insulation around the conductors can absorb moisture, leading to corrosion, shorts, and potential fire hazards. Using NM cable in a damp location like an unfinished basement or near a spa is a code violation and a safety risk. Instead, wiring methods approved for wet locations, such as conduit with appropriately rated conductors, should be used. Considering the Carflex, also known as flexible non-metallic conduit, it also needs to be suitable for wet locations. Standard Carflex may not be waterproof and could allow moisture to penetrate, leading to corrosion and electrical hazards. When used in wet locations, Carflex must be specifically listed for such applications and properly sealed to prevent moisture ingress. Regarding bonding, bonding is the process of connecting all metal parts of the spa and its equipment to the grounding system of the house. This includes the metal frame of the spa, the metal parts of the pump and heater, and any metal piping connected to the spa. Bonding ensures that all these metal parts are at the same electrical potential, which minimizes the risk of electric shock if there is a fault in the electrical system. The lack of bonding can create a dangerous situation where different metal parts have different electrical potentials, leading to a shock hazard if someone touches 2 of these parts simultaneously. Finally, ventilation in the basement is important to prevent moisture buildup, which can lead to mold growth and corrosion of electrical components. Proper ventilation helps to maintain a dry environment, reducing the risk of electrical hazards and improving the overall air quality in the basement. This can be achieved through the use of exhaust fans, dehumidifiers, and proper insulation. In summary, addressing these code violations and additional concerns is essential to ensure the safety of anyone using the spa and to protect the property from electrical hazards. Always consult with a qualified electrician to ensure that all electrical work is performed in compliance with the NEC and local codes. The NEC is a comprehensive set of standards that govern electrical installations in the United States. It is updated every 3 years to reflect the latest technologies and safety practices. Compliance with the NEC is essential to ensure the safety of people and property. The NEC provides detailed requirements for all aspects of electrical installations, including wiring methods, overcurrent protection, grounding, and bonding. It also includes specific requirements for special occupancies, such as spas, swimming pools, and healthcare facilities. Local codes may also have additional requirements that are more stringent than the NEC. It is important to check with the local building department to determine the specific requirements for your area. A qualified electrician is trained and licensed to perform electrical work in accordance with the NEC and local codes. They have the knowledge and experience to ensure that electrical installations are safe and compliant. Hiring a qualified electrician is essential to protect your safety and property. When hiring an electrician, be sure to check their license and insurance. Also, ask for references and check their reputation online. It is important to get multiple bids before hiring an electrician. Be sure to compare the bids carefully and ask questions about any differences. The lowest bid is not always the best choice. It is important to choose an electrician who is qualified and experienced. Before starting any electrical work, the electrician should obtain the necessary permits from the local building department. This ensures that the work will be inspected and approved. Electrical inspections are performed to ensure that electrical installations are safe and compliant with the NEC and local codes. If the inspection fails, the electrician will need to correct the deficiencies and schedule a re-inspection. It is important to address any electrical code violations promptly to ensure the safety of people and property. Failure to comply with electrical codes can result in fines, penalties, and even legal action. In addition to the specific code violations discussed earlier, there are other general electrical safety tips to keep in mind. Firstly, never overload electrical circuits. Overloading a circuit can cause the wires to overheat and potentially start a fire. Secondly, use extension cords sparingly and never run them under rugs or furniture. Extension cords can overheat if they are not properly rated for the load. Thirdly, replace any damaged or frayed electrical cord immediately. Damaged cords can create a shock hazard or start a fire. Fourthly, never touch electrical appliances or switches with wet hands. Water is a conductor of electricity and can create a shock hazard. Fifthly, install ground fault circuit interrupters, or GFCIs, in areas where water is present, such as bathrooms, kitchens, and outdoor areas. GFCIs can quickly cut off power in the event of a ground fault, preventing electrical shock. Sixthly, test GFCIs regularly to ensure that they are working properly. Seventhly, have your electrical system inspected periodically by a qualified electrician. Regular inspections can help to identify potential problems before they become serious hazards. Remember, electricity is a powerful force that can be dangerous if not handled properly. By following these safety tips and complying with electrical codes, you can help to protect yourself and your property from electrical hazards. By understanding these common violations, how the electrical code applies to spas, and the importance of qualified professionals, you can ensure a safe and enjoyable spa experience. Also remember to consider the long-term costs of non-compliance, which can include fines, rework, and potential liability in the event of an accident. Taking the time to do it right from the start is always the best approach.